Mhm. Okay, guys. So the topic of today is about JavaScript performance. So I will go over some patterns, some tips, some strategies to help you to optimize your JavaScript code. So I will try to gather some strategies, some tips in a way that we can help in your workday life. So first, I will just introduce myself if somebody don't know about me. So I'm Daniel. I'm an engineer in the Pyramids team, D3. So I have been working in the JavaScript for 18 years in a lot of different projects with different needs. So, but most of those projects that I did was the main concern was the performance on the web in heavy computational process. So, such as physics, 3D, logistics, and big data with machine learning and games, web games, and etc. So, but it was mandatory to improve any tiny piece of code to gain any tiny bit of performance sometimes. So I'm enthusiast of about JavaScript performance, and in my longer career, I was writing JavaScript code and applied many different ways and patterns to achieve good performance. So some of them I will share with you today, but unfortunately, there's no time enough to share all those things. But I try to do my best to share with you some of them. But we can share, we can chat later, we can talk later if you want to go deeper in some of those topics, okay? So I hope you enjoy the content. First, the topics of today is, first I will take a look, I will try to describe a little in a superficial way how Chrome V8 Turbofan engine works. This is the engine, JavaScript engine inside the Chrome browsers, but a lot of other browsers follow some similar patterns, such as Opera and some other Chinese browsers. And also some rules, Safari and Firefox, they try to do this mostly the same. Yeah, after I will start to take talk about a little. The first tip is reusable objects. Later, I will talk about execution context, so which is with variables and scopes. We'll describe a little what is this and how to use it in a wise way. Later, I will talk about TryCatch. So most of you know about it, but somebody doesn't know what I will talk about TryCatch here. And after, I will discuss about arrays in JavaScript, how arrays works inside JavaScript, mainly in Chrome V8 Turbofan engines, okay? So after, we will talk about Object Factory, which is some different strategies to create some instance, and how to code some class. But most of you already know how to do it in a clever way, but it's good to remember some things that people sometimes forget. So, and after I will talk about hidden class, which is shapes. And after we discuss about takeaway and more tips about JavaScript performance. Okay. So first things first, as I said, it exists, this presentation was made to help you with some patterns or strategies in JavaScript code and can perform better. So it exists a long list of tips and strategies and patterns. So I select some of them. Some of those tips are old, but it's still important to remember and to use it. Some of those tips are based on Chrome V8 Turbofan and Liftoff Engine series. But yeah, probably most of you, those tips you have been using already. So let's take a look first how Chrome V8 Turbofan works. first, let's take a look inside this plus operator. Most of you think that this plus operator in JavaScript, it's more or less similar as we have in some other languages like C, C++, which is just create a machine instruction with the add instruction in CPU and just address some reference in the memory to access the A and B variables. But in JavaScript, doesn't work like that. Here we can see how the process works when we trigger the operate plus. So first, you can see that we have here. Oh, sorry, I just pressed the wrong. Okay. So first we have here the operator plus, but before to translate to compile to machine code, we have here the operator plus, try to check if it is string, if it's number, if it's primitive, go to some calls, get the virtualization and parse the object and try to do a lot of process before generate the machine code. So it's a long process for this. Yeah, so the JavaScript execution in V8 is divided in 3 stages. First, we have the source code, as you can see here, the JavaScript function source code, with syntax, this is the first stage. And after we have the syntax tree to bytecode and bytecode to machine code. So first stage, we have this parsing part, which is the parser try to generate abstract syntax tree from the source code. This is the first stage. So the second stage, it creates a bytecode. We call it syntax tree to bytecode. It generates an optimized code. So V8 try to interpret using ignition, try to generate the bytecode and from the syntax tree. So the third stage is this bytecode to machine code. So V8 compiler Turbofan generates a graph from bytecode, replacing sections of this bytecode with highly optimized machine code here. So you can see here, we have a long bar. It is not because I'm not good to draw rectangles. It's because this part here is take longer if you compare with the parsing part. So keep in mind this part here, because we can use this information here in the rest of the next tips. So the compiler here, it takes longer because we have a lot of things to process. And after that, we have the machine code, which is the optimized code here, generated from the compiler, from the Turbofan. And also now they will call liftoff engine. One side note here is, you can see here we have WASP binary here. It's just a new information here. If you have a WebAssembly code with some binary data, the WebAssembly try to skip the first stage and the second stage, and even the compiler phase, which is try to go directly here, try to skip. And here is just a small phase inside the compiler that we call decoder. So try to decode WebAssembly here and go directly to machine code. That's one of the reasons WebAssembly is so fast for web browsers, because it will skip the parsing and the compiler phase, go directly to machine code, only with this decode phase. So first, let's take a look inside the reusable objects. It's the first tip that I will show you today. Okay, you can see here two pieces of codes. They are more or less the same, you can say, but it's not the same. You can see here, it's just an example. It's just a dummy example. Don't get me wrong, but This is just to show you how big is this problem when you try to create the same object all the time in some side loops, in some side request animation frame, any kind of cycle that we have, and you try to recreate the same object over and over again. What happens is, if you can see here, I will show you here. All the time, if you try to recreate the same object, it will go from the optimized code to the unoptimized code, and sometimes goes to the first stage here, to parsing phase. So keep in mind that you try to avoid to create the same objects all the time in some cycles. So I will just go back here. So this is the best way to do for this kind of example. Instead of recreating the same object, just to create outside, just as simple as it is. But because if you try to recreate all the time, go to the first, go to the second stage, and sometimes in the bytecode stage, and sometimes go to the first stage before parsing the code. This behavior we call de-optimization, which is try to revert this part of code, recreate from scratch again. So this is a lot of, it's a heavy for the JavaScript engine. So that's one of the reasons we try to avoid this kind of pattern. So another example here is, this is a similar example as we had before, but here we try to use the prepared for that object inside some cycles. Here again, if you try to do this, again, we'll create from the scratch, start to go to the first stage, parsing, compiling, and try to generate the machine code again. Try to avoid this kind of thing. Instead of using this, try to use like here, create a constructor of these objects outside of some cycles, and just reuse, update those values inside. Here, it's okay to do it because we don't go back to the second or first stage of JavaScript engine all the time. Just when you try just to update those values, it's okay. It will keep inside the machine optimized code with machine code. So now let's take a look in execution context with variables and scopes. In JavaScript, there are two types of execution contexts. First, we have a global context. It's created when a JavaScript process is launched. Second, we have the local context, which is created when a function is invoked. So probably you might know about it. It's very much easy, simple in JavaScript. However, the execution contexts are organized into stacks. So first, at the bottom of the stack, there is always the global context. It is the window, for example. Each time a function is encountered, a new execution context is created and pushed onto the top of the stack. So once the function has finished execution, its context is popped off the stack, as you can see. Okay, it is pretty much easier, but let's consider this function here. You can see here, we have a function with some local variable with some outside variable. Whenever we call this operator here, and the JavaScript engine try to search for this one, it's first try to search inside the same scope. If it's not found, try to go up in the upper level scope. Here, in this case, it's easy, just found it here in the upper level scope. But we have some situations, we have a long chain, which is try to reach some variables that are from the beginning, from almost close to the global context. So in this case, it's much slower. because again, the JavaScript engine tried to reach this variable here. It's not here. Go to the upper level. It's not here again. Go to the up. Go again. Go until reach this this variable here. So if you don't need to use like this, if you really think, okay, I can't put inside the local scope, and we know it will not create all the time in some cycles, in a way that you don't need to parse and compile again that variable or object, it's better sometimes to use like this, as simple as it is. So it's much faster, it's faster to find, it's faster to compile and translate to, transform as a machine code. So this is the best way for now, for this. However, keep in mind that if you call this function here all the time in some loop, some cycles, or even in some request termination frame, try to avoid create all the time the same object here. If it's just some primitives, it's more or less okay. But if you need to recreate those objects, huge objects with a long list of operators, try to avoid this kind of thing and put this in the upper level that don't be inside some cycles. Another thing that you need to consider about variables, scopes, and arguments is this kind of thing here. Let's take a look at this method in some different ways to call those arguments. So when arguments are being passed to a function, it's important they are in the same time. So Chrome Turbofan try to check these things. For example, if you have here the first part when you call, we have just integer here. It's okay. We call monomorphic type. So in this phase here, the Turbofan try to optimize this function. Okay, it's optimized. It's generated the machine code. It's fine. However, in the second part here, it's try to the Turbofan check if it's different. There are different types of arguments. In this case, go back to the second stage in JavaScript Engine, and sometimes go to the first stage, the first phase, which is the parse phase, and try to parse it, generate the bytecode here, and try to compile it again. So, but in this case here, in the third time, we change the type of arguments. We change it again. So the engine go back to the parse phase, compile, and translate to machine code. And the fourth step here, in the fourth time here, we change it again. And we change it again with megamorphic types. When it happens, what happens here is Turbofan will give up after the fourth try if the types are different. So after the fourth tries here, the Turbofan will not optimize that function anymore. So it will keep as it is with with the bytecode, not with the machine code anymore. So keep in mind to avoid change the types, even if you try to change after the third or the fourth time. Otherwise, you have code totally slow code. So let's take a look about TryCatch. So TryCatch code is hard to optimize. So let's take a look at this, just a simple TryCatch code. So the TryCatch code is hard to optimize for some browsers because most operations inside the try block can cause an exception, as you know, and go to the catch and allocate more temporary memory for this exception. So this flow is too expensive to model precisely inside the JavaScript compiler that we call just-in-time compiler engine inside the Turbofan Chrome browser. So try to avoid this TryCatch. However, after the Turbofan V8 node 6, which is the version 6, we don't need to care about this anymore because the TryCatch is totally optimized after this version here. However, it's not optimized yet in some Safari version, in some Internet Explorer, and even in the Edge, Microsoft Edge. So if you have some users or customers that still using Internet Explorer, Edge, or Safari, some Safari versions, and you have this TryCatch in some cycles or some complex functions that it call all the time, very often. So try to avoid this TryCatch, use some if statement with safeguards, try to use different strategies because it's not optimized at all in some other browsers. But if your user or clients just use the latest Chrome, you are good to go. We can use TryCatch as much as you want. Let's talk about arrays. To optimize arrays, the best, the Turbofan, the Chrome V8 Turbofan, keeps track of which kind of element the array contains. So the V8 difference between 6 types of elements. So let's take a look here. First, we have the default array version, which is just an integer. If you don't define the type of array, it will automatically create the packed SMI elements type of array, which is just based on an integer. If you have float numbers, we call packed double elements. It's a different type of array. If you call packed elements with strings, so which is those things, those arrays that has float strings in any kind of normal primitive values. However, if you have undefined or values inside, we call whole SMI elements. So which is just a kind of open and totally open array. Whole arrays, they are much slower and harder to optimize inside the code. So here we have SMI, the double, and even whole elements. Let's take a look at some examples here. So elements types can change, as you know. If you change your array on the fly, like below here, it gets transformed into the next state of elements kinds. Okay, so you can transform elements types from specific to generic, but never backwards. So if you have a whole elements array, for example, it stays whole forever and takes longer to optimize, as I said before. So this strategy here to populate the array is much less efficient than if you try to populate at once in one single shot. So if you know in advance all those information, instead of just populate inside some for loop, try to use these because it will convert in only one time. So because here, if you, for example, this example here, first it will allocate the array with just a type SMA elements, just with the integer. So after just populate again with just integer. After the JavaScript engine, we realize that there are different arrays. Try to allocate memory here and convert. After change again the type of array because this is just packed elements. So in this case, allocates and convert again. And after here, we have undefined. This is totally whole elements. This is the worst scenario of arrays. So it tries to allocate, convert, but this is much slower array type to optimize. So again, keep in mind, if you know already those elements in advance, try to avoid this kind of populated strategies. Try to populate it in its constructor. So let's talk about a little about Object Factory. Maybe you know, maybe not. We have different ways to create instance in JavaScript. But let's take a look the one old-fashioned way to create instance based on some kind of class in JavaScript. This is a kind of vanilla JavaScript. but it's I have been seeing this a lot of times in different projects still. So probably you know about it already, but it's good to refresh this kind of thing again. So you can see here we just describe some class with some methods here, and we return those methods. And here is just a simulation. You can see I tried to create 1 million elements inside the array, just to show how much memory it will allocate only recreating all those methods inside the same kind of element in an array. So you can see here, only with these methods, when 1 million elements, we allocate more or less 200 megabytes here. It's huge for just simple things. Of course, it is 1 million elements inside the array. This is not like a real scenario, but you need to keep in mind that this cloning method here is useless. You don't need this, just because it's just is the same class for any instance. We can reuse from, as we speak later, we can use based on prototypes. So this is the second way. This is again is the old-fashioned way to generate classes in JavaScript, but in this case it's much better. Here we can see that we create those methods based on prototypes. So which is in prototypes, we just use define those methods inside the prototype, and each new instance we will connect, more or less connect to the prototype. You will not recreate all the time those methods for each instance here. So here, with the same amount of elements, we allocate only 29 megabytes. It's a huge difference, right? Okay, let's take a look another way. This is the old-fashioned way. If you see this kind of code in some vanilla JavaScript project, you can please try to rewrite it, because you will try to use similar approach of prototypes, but it will allocate a little more memory here, because this object create try to use the base and put a lot more things inside. So here we can see an example. It will allocate 33 megabytes, a little more, but it's useless now, because now we can still still use prototypes. And also we can use now with ES6, you can use the better way to do classes based on extents, of course. So here in extents, you can see that we extend the class, of course, and they use inside only the difference inside the constructor. And whenever you call, we create an instance, it will generate those methods only inside the prototype. In the end, is much the same way as we had before with prototypes, just the better way to implement, the clever way to implement. So if you see here inside the snapshot, you can see that it will allocate exactly the same amount of memory as we had before with prototypes. But it's much cleverer way to code, right? You can see here these methods are inside the proto, which is the prototype, not in each element instance, but only inside the prototype. Try to reuse the same methods. So whenever you see codes like this, try to use extents with all those methods that you don't need to replicate in each instance. Try to move all those methods that we only need inside the base class. Try to put it there. You will allocate much less memory. So now let's talk about hidden classes. So JavaScript engines generate shapes of each object that we create. So similar objects share the same shape that we call hidden class. In some browsers like SpiderMonkey Engine, which is the engine inside the Firefox, they will call shapes. In V8, we call maps. Inside the Edge, Microsoft Edge, in Chakra, we call types. And in Safari, we call structures. So let's consider this. We have two objects here, the object A and object B. You can see they are more or less the same, right? Because they have the same shape. Object A shares a shape with object B, which is the, so in this case, the engine doesn't need to allocate additional memory for each object shape. So it only needs to store its values, as we can see here. So, however, keep in mind all the time to keep the same order and the same way you initialize your objects. Otherwise, the JavaScript engine will not recognize that they are using the same shape. If you have similar shapes like this, similar objects like this, try to keep the same order, even for properties like she, X, I, and Z. Here. They are the same order. If you switch, if you shuffle this, the browser will not recognize. Let's see another example here. Let's assume this, this code here above. So if you think that all objects are the same, if you, as a JavaScript developer, most of the time you think that they are mostly the same objects, right? Object A is the same of object B, object C, and object D. They are mostly the same. But for JavaScript Engine, they are not the same. The order and the way you initialize and declare your objects is significantly essential here. So in this case, the object A and object B and object C will not have the same shape. We call hidden class, right? And so V8 cannot optimize them concerning their hidden classes. But object D instead have the same shape here. So in this case, we have only the same shape sharing across object A and object D. So keep in mind all the time if you need to do this. So more on some more information here. It's good if you want to go deeply and deeper inside how the V8 works, how to debug the optimization process, and how the garbage collection works inside the V8. You can use these flags here, the trace optimization and trace de-optimization. And also have the trace GC here, which is logs a tracing line on each garbage collection. It's good to understand how the V8 works, and you can optimize your code based on these logs. So the conclusion, first, avoid to create objects over and over in loops, okay? In for loops, in regression animation frame loops, in any kind of cycles that call twice, more than one. So try to use those, okay? Otherwise, we'll go, it will go to parsing and compiling phase in the just-in-time engine over and over and over again, okay? Avoid using global variables. Local variables are faster. Remember to use const for static values. You might know that why we use const, right? Because they are static values. But some people doesn't know that is how we proceed inside the engine. So the const, what happens is if you have const variables inside the machine code, it will translate to the real value instead of the variable. If you have just a let or var variables, it will redirect with the reference inside the memory. But if you create a const, instead of redirecting to the reference of the object of the variable, it will transform the instruction inside the machine code with the direct value of that const. That's one of the reasons it's much faster to use const if you don't need to change the values after its creation. So again, don't change the variable type at runtime, please. Otherwise, it will revert the first or the second phase of the compiling process. So avoid to create whole arrays. Try to use the packet arrays, okay, in its construction. It's much important to think about it, if you can do it, of course. Try to use the same object shape if you need it to create more than one object. It's including the same property order, of course. Try to use prototype strategies. In this case, extends for ES6 to decrease memory allocation. So if you have similar functions methods, use it for more than one object instance. It's good to keep in mind this in order to decrease the memory allocation. So more tips. If you want, I will show you more tips. Here, please don't use eval. If you use eval in your code, please remove it, because you have a lot of problems in security issues. You have a lot of security issues, and it's much slow. So use it only if you cannot use another way around evals. Remove all reference of variables and objects when they are not used anymore. You can use null to remove the reference. Remember, in JavaScript, if you put an object or a property equal to null, you will not delete that object. You will, for objects and arrays mainly, you will not remove the object. You will just clean that reference. And if you don't have any more references for the same object or array, it will clean it by the garbage collector. So keep in mind to remove, assign it to a null or even define it. But Chrome teams, they will recommend to use null, just to assign it to be removed if you don't have any references for that object anymore. So try to use this approach and keep in mind this remove, otherwise you have a lot of memory leaks. So the garbage collector is your friend. Use it in your favor. And also use the Chrome profiler to analyze the GC when it's running. If you don't know how to use the profiler, we can talk it later. I can explain how to use the snapshots, how to profile the performance using throttling, and have a lot of tools inside the Chrome to analyze the garbage collector and see where it's failing, where is the memory leaks, when the garbage collector is calling all the time. So it's a good tool to debug your code. If you want more information about the garbage collector, I have this link here. It's useful for more description about it. So don't create big functions. Sometimes they're not optimized. I mean, big functions are huge functions with a lot of codes inside. If you have some such of these kind of functions, the JavaScript engine will not optimize it at all. Some vendors, some browser vendors, they said if you have functions that they are more than 64 kilobytes, it will skip to optimize. But I saw before, even less kilobytes inside function, you will not optimize it. So try to be short inside your functions. Try to decomposing in more functions. So in this case, it will be much easier for the JavaScript engine optimize it. So use the for in instead of object key for object interactions. So it is a thing that people think that for in is slow, but if you compare with object key to create interactions using objects, it's much faster for in. Also, the good tip here, use the function cache strategies we call memoization. Most of the time we can use it when you have functional programming, but you can use it in different ways. If you don't know what this is, just to summarize, cache strategies you can use when you have the same input and it will generate the same output. If you have the same input with the same output all the time, you can cache your output. So whenever you check, the function has the functionality to check if it is the same inputs, you don't need to calculate again. We can just return directly the same output as we had before. So another tip is try to use primitive process because instead of functional calls sometimes, because sometimes primitive process can be faster if you compare with function calls. Mainly in other browsers. In Chrome, we don't have too much this problem in some function calls. But in Edge, Microsoft Edge, for example, we have this kind of problem. I can show you with this perform here. Let's take a look here. So here it's a Chrome. If you run this test here that I did, you can see here, this is a functional call, just to call check the mean, and just to call the push here. You can see, right? And here, the primitive operation is the same, but we use the ternary operation, and we just call directly the element inside the array instead of using the push method. Here in Chrome, most of the time, primitive operations is more or less close each other with the function calls, but sometimes you see it's more or less the same, 64, 63. However, if you go to the Microsoft Edge, if you run the same test, let's run it. It's still running. It's a little slow, but let's see. Okay, you can see here, the functional calls is much, much slower. You can see 15 times and 70 times. So again, if your user, your clients use Microsoft Edge, try to avoid this kind of thing if it's possible, of course, in some huge loops like this. Okay, so let's move on. More tips here. If you want to rock and roll even more with web performance, I strictly recommend you to take a look in the web workers for multi-thread processors. I still recommend for GPU, for parallel review calculus using GPU hardware. We have some frameworks to use this kind of thing. We call GPU.js and Turbo.js. This strategy here is to use the graphic card from the client computer to process some heavy calculus instead of the CPU, because sometimes the GPU is much faster to have this kind of calculus. But of course, depending on the case, you need to analyze. But please take a look. This kind of frameworks is it's amazing tools to use this heavy calculus here. And again, try to take a look in the WebAssembly to achieve almost native performance. So as I showed you before, WebAssembly skip the parse and the compiling phase inside the JavaScript engine. Go almost directly to the machine code. But keep in mind that not all the time it works. You need to know what is the pitfall inside WebAssembly in order to perform it in a good manner. However, again, this is a thing that you need to consider as well. Try to avoid micro-optimizing your JavaScript. That can be just a wasting time, okay? It may be cool to know that the browser can execute one version of a thing 100 times faster than another thing, but like that, requesting elements, for example, like requesting an element's offset top is faster than computing get bounding client rect, for example. But it's almost always true that you will only be calling functions like these in a small number of times per frame. So it's normally wasted effort to focus on this aspect of JavaScript performance. So you will typically only save fractions of milliseconds. However, if you're making games, or even if you're creating computationally expensive applications with a heavy calculus or heavy process using JavaScript, then you're likely an exception. So to this guidance, so as you will be typically feeding a lot of computational into a single frame. So in this case, it's every kind of improvement counts. Okay, so that's all. Thank you very much. Here we have some references. Here you can see some references here. Also, I will share this presentation if you want to take a look again and see other links that I share here. And thank you guys. That's all for me.